Have your great day, everyone. Welcome back. Today, I'll be demonstrating an architectural addition and alteration project using Autodesk Revit. This project is close to my heart, recalling my early experience in the construction industry in my hometown when I'm being served as a civil servant in construction industry. I will focus on key modeling techniques and important steps without covering every detail. By the way, I encourage you to visit my channel for various kinds of model creation. Let's start with step-by-step build the model. Part 1. Building the original model. 1. Starting a new Revit project. Open Revit and start a new project using the metric architectural template. Building the original model. 2. We're now start to create grids. First of all, use shortcut, GR, to create horizontal grids numbered 1 through 5. Use shortcut, DI, to dimension and adjust grid spacing. Then create vertical grids labeled A through J and adjusting their spacing as well. Building the original model. 3. Setting levels. Navigate to an elevation view. I'll work from south elevation. Currently, 2 default levels by system. Rename level 0 to platform and set it to 50 mm. Set level 1 at 450 mm above platform. Add levels up to level 6 extending the range for all levels and grids. Rename all levels. For example, level 1 to FL1, level 2 to FL2, and so on. Set floor to floor heights at 5000 mm and 4500 mm, which may be quite high. Now, the grids and levels are set up. Building the original model. 4. Installing columns. Open both floor plan and 3D views for better understanding. Use architectural columns for now. Duplicate and edit types to create columns of various sizes, such as 400 by 1000 mm, 400 by 400 mm, and 400 by 1200 mm. Install the 400 by 1200 mm columns on the ground floor at grid intersections. Then copy them across all grids. All columns are installed from ground level to level 1. Building the original model. 5. Installing floor beams on FL1. Use the beam tool, shortcut is BM. Load additional beam families, and selecting rectangular concrete beams from the library. Create custom beam types with dimensions 400 by 700 mm. Set constraints for placement on FL1. To enable chain placement, install beams along X and Y both directions. Copy beams across all grids and install beams along X and Y both directions. Building the original model. 6. Installing columns on upper floors. Select columns in a window. Filter only columns, copy, and paste by clipboard installation at FL1 and FL2 levels. Building the original model. 7. Frontage facade screen installation. Use architectural walls, shortcut WA, and select a curtain wall. A suitable wall type to select from these various wall types. Let's use almost below, a curtain wall that empty type. Prepare to place curtain walls on FL1. Set unconnected height to 8000 mm with a 300 mm offset. Draw a wall line on floor edge this point to another end. Completed one panel for now. Install next 2 curtain walls of same lengths. Now, 8000 mm high curtain walls have installed for 3. Building the original model. 8. Creating a curtain panel family. Create a new family using the metric curtain wall panel template. For better approach, to work at exterior elevation. Add a reference plane, shortcut RP, place, around mid position. DI, dimension them, equal spacing and overall dimensions with 1000 mm each for both directions. This demonstration, I'll use 1000 mm square panel on the wall. RP, reference to add 2 each horizontal and vertical reference planes. DI, dimension them. Create new parameter, gap, check as type parameter. Create an extrusion geometry for frame, use rectangle. Next rectangle, offset by 90 mm, hit spacebar to inside position and end model process. Provide thickness for extrusion start from 0 to end at 300 mm. Create a new material parameter, naming with frame. Define the gap parameter with 8 mm values in the family type window. For the graphic display purpose, let's create material asset, duplicate and modify the new material asset to white color concrete material. This new material to apply for frame. Create extrusion geometry, inside frame for the panel with thickness and material parameters. I remember almost certainly, the panel pattern shape may be something like this. Add a pattern design using arcs, offset 90 mm, and move to position and mirror them. Also include a circle. Clean up all model lines. Whoa! Aesthetics pattern is formed in shape definitely. Give it extrusion values, start from 50 mm, end at 300. Perfect. Create new pattern parameter, check as type parameter. Apply with this new material. Save and load the family into the project as Screen Block 1000. This family should be found in Project Browser Palette, under Curtain Wall Panels group. Since I have a new 1000 mm family in project, edit the family type, duplicate it for a new wall type, name with Screen Facade. For curtain panel setting, replace from none to what I loaded family, it should be able to find, here, name with Screen Block 1000, this one. Followed by more settings to change. Vertical grid, layout none to fixed distance, and spacing width new screen family block size is 1000 mm. Apply the same settings to horizontal grids as well. Uncheck for adjust for mullion size for both grids. Once apply the setting and hit OK. Revit will generate a new curtain wall panel type. Let's select and apply for next to 2 panels with this new screen block type. Pretty good job is done. But interior and exterior placement looks misplaced. No worry, just to flip the panel by hit indicated directional arrow from floor plan. Well done. Completely perfect installed screen block facade within wall. Part 2. Alteration and Addition, A&A Works Alteration 1. Layout changes. I've sketched a part plan for this model. Same layout with different column sizes and their positions on additional grids as shown for better facade combination. Facade typical ideal cross section is sketched this. L-shaped beam to support facade screen block curtain wall. Here's new layout. First, to delete all column on grid 1. Also delete the curtain wall. As new layout, I'll need more column types. Create and duplicate new column types of various sizes 400 by 1400 em. 400 by 1300 em. 400 by 2200 em, etc. Install new columns as the updated layout on ground floor level. First, 400 by 1300 mm columns for 2 on grid B and C. 400 by 2200 mm columns for 2 on grid G and H. Then 400 by 1200 mm for 4 on grid A, I and J. Finally, 400 by 1100 mm columns for 2 on grid D, E and F. The rest will be unchanged remained. Alteration 2. Installing floor beams on FL1. Shortcut, BM, install 400 by 700 em beams on FL1 across grids A to J. A beam for lift shaft on grid 5, as well. Continuing on between grid 1 and 4 facade beams. These should be L-shape which were mentioned earlier. Alteration 2. Create and install L-shaped beams to support facade screen blocks. Select a beam and edit into new L-beam family. Edit the sweep geometry from rectangle profile into L-shape. 400 by 1100 mm depth beam and overall 1200 wide slab on top. Same structural material parameter to use. Save as file name with rectangular beam L. Load into project and start install each beam separately on FL1 on frontage all grids. Shortcut AL, for align beam edge to frontage column face. Lengthen the beam in between column positions. Install L beams to support curtain wall at frontage all spans. Alteration 3, installing walls. As actual work design, to install interior walls and windows behind the screen block wall on FL1. WA, for wall, choose a suitable basic wall type, from system wall family, and duplicate the type, rename it for 1/15 thick wall, edit the structure. Install the wall on FL1, and 2000 mm height, setting the wall position to interior. For demonstration purpose, install on frontage grids only. No wall for exterior and partitions will be done. Alteration 4, installing floors. Use system architectural floor, duplicate the floor type. Remove unnecessary component. Install on FL1, by rectangle model line, required to add lines, trim them to form the slab edges as building boundary. Including boundaries for stairs and lift shafts. Turn on the shadow for better viewing experience. Alteration 5. Components to install to upper levels. Select all components on FL1. Copy floors, beams, and other structural components to install levels FL2 through FL5. Use filter option, check for floors and structural framing components only. Hit OK to generate the installation. Again, select all columns, then copy and install to above selected levels FL1 through FL4. Use side view and select components on frontage, which are from floor level 5 to level 2 by window selection. Filter for structural framing only for all L-shaped beams. Then replace with commonly used type, 400 by 700 mm beam and properties palette. Perfect. In addition, let's add 2 more floor levels above. Then copy and install all components on new floor 5 and 6. All good. Alteration 6. Remove and alter some components. Remove some columns and floor beams at almost top left corner for design purposes. Part of floor slabs to shape different forms as well. Install additional 400 by 2200 mm columns of 2 on floor level 7. With unconnected height of 8000 mm. Finally, install a beam L at that level. Alteration 7. Additional structural work. Create for cantilevered porch on ground level, between grid G and H. Use model in place component, place under category of structural connections, name 2, lobby porch. Working on east, or west elevation, to create an extrusion, set working plane to grid, G. Start with rectangular model lines, lower down by 700 mm. Then to form this, cantilever shape up. Give negative 200 mm for start extrusion and end at 200 mm to cover column depth of 400. Assign material to concrete cast in place, white, and finish a model for porch beam. Copy and clipboard paste to install at same location for another beam. Move 7,400 mm for second beam to reach next to grid H. Next to create a porch roof 150 mm thick slab at soffit of that beams by picking the edge. Apply extrusion values with start 700 mm and end at negative 8,100 mm. And also to assign material asset to concrete white. Select and join geometries for all three components. And finish the model. Install stairs on ground level. Use architectural stair component, choose cast in situ concrete 150 mm waste type. Constraint setting, base level at ground floor level, and no offset and top level to floor level FL1. Edit types for stair minimum run width 1500 mm for public use. Revit steps calculation 33 risers were shown in properties palette. Let's run the stair flight for 7 risers, then first landing at edge. Continue running flight up to 20 risers at left 90 degrees, then next landing again. Next flight to run back 180 degrees to complete till full risers. AL, align stair edge to beam, then above flight to first landing. End the stair creation mode, and move the stair to position of beam. Go to 3D view, remove all railings for now, in this model. Here's a stair installation completed on ground level. Next, to install stair on floor level FL1 connect to FL2. Same process as previous, this case 2 flights to run, due to floor height reduced. This stair, FL1, to FL2, Revit calculated as 27 risers in total. So, run for below flight 14 riser first and 13 risers. And remove all railings for this project. Copy and install on above each levels up to FL6. Lift shaft wall to build. Use 150 mm thick basic wall, and set some setting for wall. Location line to finish face exterior, base constraint place on ground floor level, FL1, for top constraint, top offset should be, beam depth below, negative 700 mm. Install by rectangle path, and align to beam faces. Select a front wall. And modify the wall profile to add 2 openings for lift doors. All walls to copy and install for each level above up to FL7 roof slab. Create a ramp here on ground floor level. Can be used the ramp, but simply use architectural floor as same floor type. One more element for next to it as well. Use modify sub-element for the ramp bottom 2 points to be lowered down by 450 mm. Done. For 2 ramps. The step for entrance lobby. Use stair. Placement on platform level, top constraint will be ground floor level. Edit type for tread width to wider 500 mm. And run the stair. This stair will have only 3 risers. After rub, align to floor edge. Finished first and remove railing. Stair width to 7,000 mm for between 2 columns. Align to one of the columns side. Add a S platform slab using same floor type floor, with enough coverage over the building premise. Let's move on for upper part of building. This floor and below floor to install parapet wall. And above roof slab to end up installation with parameter parapet wall as well. Parapet wall installation. Use model in place family. And category under structural connection. Name to FL7 parapet. Model with sweep tool. Set working plane by pick working plane. Select to roof top floor slab for wall path. Then to sketch a path. Select this edge. Next. Next. Up to reaching lobby column. Ensure all path lines must connect at each other. Then to draw a parapet profile, here. Easier practice, draw from east, or, west elevation. Draw a rectangle, 150 mm by 1800 mm, end up with this shape, like this. First, this geometry copy to clipboard for next usage. Assign material to same white material. And the model process for the parapet. Yes. Completed installation on the roof. Next one for below floor level 6, create path and same profile from clipboard to do so. And last short length parapet wall below FL5 as well. All good. Reinstalled back curtain walls facade as new layout. I'm going to use it back the curtain wall panel type, screen facade which created in starting stage. WA, for wall command. Placement on floor level, FL1, top constraint to floor level, FL5. Top offset, below L-shape beam, should be negative 400 mm. Apply the setting and start a placement line. This floor edge to next this point. Revit has generated with screen block facade panel. Flip the panel by the directional arrow. Done. Let's continue for next panel. Top constraint to raise one level up, it's to floor level, FL6. Draw a placement line and flip it. Next panel, top constraint to floor level, FL7. Placement line to be longer to entrance porch, it's a wider panel. And next for above porch. Top constraint floor level, FL7, above lobby, this panel is tallest, beyond 8,000 height minus 400 mm. Its would be 7,600 mm unconnected height. This is a taller panel. Finally, to complete, and last two panels at right to end at level 7. All done. I've completed the facade screen installation using curtain wall panel wall. Facade has a simple design and lacks features that create a sense of excitement. Additional enhancements. 1. Adding more features with coloring. Introduce vibrant colors by creating new material assets and applying them to facade panels. Let's create more material parameters. I already having a color of white asset. Now, duplicate this to create a few more color assets. How about color for gray? Next for pink, as well. Create more with navy asset, dark ocean blue. Do more with Avogadro green asset as well. Also, ivory color asset, light and dim the yellow. Select a block family and panel, unlock it. Select more below and unlock them. Assign with navy material in properties palette to selected components. Repeat select and unpin for another two families, assign with Avogadro green. Next to assign with pink material. How about next three locations? With gray. Ivory for some components, as well. Haha, something changed in view. Do you feel, still lacks of excitement? Additional enhancements. 2. Create larger screen block panels and replace existing ones for visual variety. Let's edit screen block 1000 family. Create into 2 times size. Delete the frame, and edit the inner screen pattern, copy to clipboard memory for next usage. Then delete it. Resize the reference lines to 2000 by 2000 mm. Create extrusion for new frame. 2 rectangles with 100 mm offset. Same start and end extrusion to apply. White material to assign for the frame and end the frame model. Next, Extrusion to create for inner pattern. Paste from clipboard memory a screen boundary to center a family. Scale to enlarge it. Apply extrusion values and assign the material. End the model and save as new family. Name with screen block 2000, save to somewhere in computer. Then load into project. This would be able to find in project browser, under group of curtain wall panel. A new panel family type in project. Now, let's repeat modification for another 3000 by 3000 mm family. I'll skip the modeling steps, save with new family name, then load into project. I have now different 3 types of families with same pattern in project. Additional enhancements. 3. Replace existing ones for visual variety. Locate to facade and over on grid, select by tab key. Unpin to allow removing the segment of grids, and delete the type. Repeat for below grid and side also, then remove them. Leftover all grids to be removed are required. Aim to 9 blocks occupants for 3000 by 3000 size. It became a system panel back. Select individually for this particular panel. And go to Properties palette, search for already loaded 3000 by 300 type and replace. Yes, I have. For more, select Inner Pattern Components and assign Pink Material Asset. Next, repeat for 2000 by 2000 mm family replacement. Remove the grids and replace with that 2x size family. Assign material to Avogadro. Next to try for 3000 by 3000 families replacement. Doing more families replacement. Additional enhancements. 4. Add canopy shades to facade probably, using model in place sweeps. Category to structural connection. And given name for component facade 1. Create the model by sweep, or, extrusion, blend, to use suitable tool, so on. This case I will go with sweep. Pick working plane to this vertical face of facade, or, column. Sketch the boundary like that on edge of curtain panel. And OK to proceed next profile step. Profile position is here. And draw a profile with 400 height. And 1400 mm extrude out to get this shape. Then OK to generate the sweep process. And apply white material for it. Repeat for next to left large panel as same process. Each model in place, name, category, set working plane. Prepare a path for sweep. This time, the path should be 3 sides only, instead of 4. Draw a profile. This time profile extrusion depth to reduce to have some visual effect. Profile size, 400 by 1000 mm to reduce. Assign same material. Completed for large panel. Let's install and completed the structural components on roof deck. Build up for stair shaft walls and roof slab. Also roof slabs for lift shaft. Some supporting columns. Structural beams. Link the roof slab. Additional enhancements. 5. Placing signage on the parapet wall and larger this place would be blocked by the canopy shade if observed from low elevation. Let's install here. Set working plane to parapet wall face. Use model text option. Edit the text. Ministry of Information. Place the logo text sign to here. Additional enhancements. 6. Adding a flagpole behind parapet wall. Use revolve tool to create a pole shape with suitable height. Draw a half pole profile and axis for placement. Conclusion. I've been finalized this model. Place a water tank. Install a satellite receiver dish as well. Here are some visual renders from different angles. Street views are captured. Entrance lobby. Visual facade variety for additional enhancements. Completed with some detailings and ancillary features as well. This project reflects both my past experience and current skills in Revit. I did this physically before. I'm doing now for alteration and addition works on this model project. The model is now completed. Though the building was once state-owned, its current status is uncertain, illegally already belonged to someone else, and it does not appear on Google Maps. Thank you for your attention. Please feel free to share your thoughts or questions in the comments. See you next time. Thank you, bye.